Alrighty, beginning process, step 1 and 2. There's much background data not included here to keep the presentation shorter. For the most part, we'll try to keep only the pertinent information included and assume that you have experience with pH meters and an ORP meter. pH standing for potential hydrogen, and ORP standing for oxygen reducing potential. Not sure why they are labeled this way, as oxygen tears things apart and hydrogen turns oxides to metal. Clearly they are two essentials in this universe. So the pH and ORP meter would be used more on the second step. And I haven't actually been using them for a while, but we'll get into that in detail at some point. While researching, the first thing that was found was that iron hides many other elements. Once a path was found to break iron bonds, this path led to other observations. The process is founded on breaking iron bonds. What was not known until more recently is that gold is magnetic in a nano form more often than not. Nanogold will occur in nature with magnetic metals. This also brings us to another conclusion. While lead is a good collector for metallic gold, it is the worst for nanogold. Then nickel is a choice for a collector and a smelt. At this time, only 3 of the precious metals can be collected using this process. Platinum and rhodium are observed to be present, but do not have a process for them. There are ideas for collecting them, but this will be uncovered by a student along the way and shared with the group, hopefully. If the ore is ground to a -80 mesh, or about the same as flour, that is the first step. The next step is to treat the ore in a mixture of water and 80 grams of salicylic acid. If you live in the city, there may be chlorine in the water, then use distilled water. 4,000 milliliters to 1 pound of ore, or 454 grams. Salicylic acid is not readily soluble in water. Then 300 milliliters of 91% alcohol is added as well. One should always add the ore slowly to make sure there is not a reaction. I use a 5,000 ml beaker. At about 128 degrees Fahrenheit, the salicylic goes into solution. 300 milliliters of alcohol. At 300 milliliters of alcohol, the mixture is just under 10% alcohol. The solution is not flammable. At 25% alcohol, the mixture becomes flammable. Now one is going to heat and stir, getting the mixture up to about 160 degrees Fahrenheit for the next 18 hours. If you can see a white residue on the surface after it is hot and stirred for several hours, one can add more alcohol to keep the salicylic in solution. If the solution is heated higher than 160, the alcohol will disappear faster. If one runs the solution at 145 degrees, less alcohol will be added. On average, every 8 hours, one will add 100 milliliters of alcohol. And if the last 100 is added an hour before filtering, it is easier to filter. One wants the salicylic in solution during filtering, where the salicylic will be in the ore. That means if filter as hot as possible and as quickly as possible. Rinse with hot alcohol. The alcohol is heated in a large beaker about half full of water. One never puts alcohol in a beaker on a hot plate. Typically in about 6 hours, you will see a portion of the iron turn into an iron oxide. An inexpensive hot plate and variable speed overhead mixer will do the job. Also, it is important to keep the mixture covered, or a lot less of the mixture will be lost. A hole can be drilled into a small plastic gold pan, and and the shaft of the mixer is inserted through the hole and fixed to the mixer. In this step, all one has to do is monitor the mixture to make sure it does not need more alcohol. At this step, about 6 hours in, the iron begins to turn into an iron oxide, which means your mixture will start turning red. It will be removed in the next step. It is here where one can often see very tiny yellow particles showing while it is mixing, and often is easier to see if one turns off the mixture for a short time and observes the microscopic yellow particles moving through the iron oxide. Some of the earliest recoveries were made from heavy black volcanic rock, which few can assay, let alone recover precious metals from it. Using leather gloves, one can pick up the hot beaker and begin filtering at the end of the process. As one filters, and when the solution hits the cold flask, one will see the salcidic reform as a solid. The solution is saved and 10 millimeters of sulfuric acid is added and mixed in the bottle and then added to a refrigerator. Once the solution is cooled to about 40 degrees Fahrenheit, one can filter out the salcidic as a solid. One should recover about 50 grams after drying, which can be reused. Of note, salcidic acid is used in aspirin, and if it is dry, the dust will burn your nose, so a paper mask should be worn. Once the material is dry, you have, you have kept the salcidic in solution, hot, and rinse, filter with alcohol. Your end product should be about 454 grams of ore, or maybe 10 grams less. Once the ore has been treated and is dried, one weighs it and moves to the next step. Here one often sees more of a reaction as the iron goes into solution. Also of note, we are just breaking iron bonds and removing as much iron as possible and actually turning the iron into a known substance such as oxide. Also of note is understood that one has common knowledge of acids and how to handle them and when to work under a fume hood when necessary. While all the acids are considered organic that we're using in this process, in concentrated form, they will burn. Always wear eye protection while pouring concentrated acid. One tiny drop can cause a lot of misery. The residue is dried, filtered, and all on a hot plate at low temperature. 200 degrees Fahrenheit will work. This is weighed and noted in your lab notes. Now we go back to the same stirring and heating procedure, and now the temperature will be closer to 120 degrees Fahrenheit. And again, once we have our solution in the beaker, we will add the ore slowly, watching for a reaction, foam. I use a tablespoon as soon as the foam goes away and keep adding. The initial temperature on the water is about 100 degrees from the tap, in my case well water, so it may take a couple of hours to reach 140 degrees. The acetic is 99%, the phosphoric is 75%, and the hydrogen peroxide used is 35%, and the water is 3,000 milliliters. This procedure is started with 2,500 milliliters of water, and after initial reaction, another 500 ml is added later. This step has been called APP, acidic, phosphoric, and peroxide. This step is usually run at least 48 hours. In some cases, one may have to run 72 hours. The peroxide is only added initially as an activator. This step can be filtered and cooled. This step can be filtered cool. In other words, you can let it stand and settle out. Usually after the initial 48 hours on heat and mix, the mixer is removed and is allowed to settle for another 24 hours on heat without the mixer. This makes it easier to filter once the sediment has dropped out. Beyond that, the filter is put on a Pyrex dish and dried on a hot plate. Low heat is better, maybe 200 degrees Fahrenheit. It is crucial that the material is completely dried as one records the weight. One should lose 20 to 25% of the original weight at the end of this step. This is the first two steps of converting as much iron as possible to iron oxide and then removing that iron oxide. Your ore after the APP leach should change colors. In the next video will be on how to stabilize the metals and coax the gold and silver and palladium away from the remaining iron. In short, we will take the dried material, we're going to use 60 grams in this case, and fire that into nickel using added precious metals as seed. On average, for 2 grams of gold added, we will get an additional half to 1 gram of gold in return. And that's per 60 grams of ore. Also, we will get the same amount of palladium and silver from the same 60 grams of ore. And at length, then one scales up to running 1 pound runs. Still working on how to get higher yields. One idea is in the works. We will also be adding safer 2 of the radiation scale, alpha and beta, at the end of the smelt. So there'll be a video on the smelting process. One can pour half-pound runs with a small gas-fired furnace. Nickel has an interesting property. As little as 3 to 4%, it'll gain a yellow color. There's a lot to be covered on how to make the lab notes. It'll have to be its own video. You need to keep very close track of everything you do, step by step. You'll be taking samples at each step, including the ore, before being treated, which we call a head ore. Approximately 5 to 7 grams are compressed into a plastic cup. This is done by cutting the top lip from one cup, adding the sample, and then when the shortened cup is pressed into the uncut cup and the lid is added, one can XRF the bottom of the cup. A few will argue there are values in the plastic. In our case, this is minimal, and so far after 2 years of testing, the values shown by XRF are very close to the actual recovered metal. And of course, you label each cup so that when the results return, one can add the data to the lab notes for your assay. You also learn the chemical notations for elements. Ag is silver, Pd is palladium, Rh is rhodium, gold is Au, etc. There is also the head ore assay, the salicylic leach assay, and I believe it's the APP assay as well. So you actually have 3. And then the button. So you have the head ore, you have the silic leach, you have the APP sample, and the button. So it's 4. To keep this brief, one then calculates these numbers against the weight of the button and the ore used for the smelt, and this is your recovery, including the seed. Your assay will calculate, well, it's actually excluding the seed. Your assay will calculate the values less the seed. So basically, I have to figure out some way to get documents to you. I'm not sure how I'm going to do that. I'm working on a website at the moment, but I want you to be able to print these out so you have and can read them as opposed to a video. And that's what I'm working on. So we'll figure it out as we go. Thanks.